Here's my watch list for the neighborhoods most sensitive to destructive winds before the storm arrives. The Columbia Gorge from Washougal to Vancouver, downstream from Natchez Pass, from Enumclaw to Black Diamond, the Snoqualmie River outflow from North Bend toward Issaquah, the Fraser River outflow from Linden to Bellingham. Another sensitive spot, the north end of Hood Canal. Frequently, strong westerly winds slam into Whidbey Island, and from Mukilteo to Marysville.
It can be disastrous.
You've no doubt heard the term Pineapple Express, a phrase coined to describe the virtual hose of moisture pointed straight at the northwest.
Not only does it bring very heavy rain to the lowlands, but because it's so warm, it forces the snow level to go way up. That ends up melting a lot of lower elevation snow that's already fallen. The combination of that melting snow and torrential rainfall makes widespread northwest flooding a certainty. You'll remember the most recent Pineapple Express event. It's the one that struck just last December. Hardest hit this time was the southwestern corner of the state, as days of warm rain made for massive flooding of the Chehalis Valley. One spot near the Willapa Hills recorded 9 inches of rain within 24 hours. Part of I-5 was shut down as the water overtook the land, destroying countless homes and businesses. Although the Chehalis Valley bore the brunt of last year's flooding, many communities are vulnerable in such a scenario.
Man-made levees like this surround most of the rivers in western Washington, but when flooding's in the forecast, you need to sandbag too.
Well, we could start at the Nooksack and work all the way down to Lewis County.
Okay.
Skagit County is probably the second worst river on the west coast.
The Army Corps of Engineers works with dike districts around western Washington to prepare for the next round of rising water. On this crisp autumn afternoon, Eric Winters helped the Corps perfect their sandbagging technique. They'll then go on to train others in communities all around Puget Sound. Sometimes the levees and sandbags can only help so much, and the race is on to protect lives and preserve livelihoods. Raised platforms of soil called farm pads are becoming a popular means for farmers to gather livestock and machinery when all else fails. Because sometimes it really does rain too much in Seattle.
Around here, snow can fall as early as October or as late as mid-April. When it does fall, it may just dust a few locations, causing minor school delays and a little bit of excitement. Other times, it can cripple cities and strand thousands. Meteorologist Chris Warren takes a look at why it can vary so widely, depending on where you live.
Snow, a 4-letter word and one we do not throw around lightly. It can change your plans for better or worse. When there's talk of snow, there are specific ingredients we look for. To see snow in western Washington, it's a pretty simple recipe. We need freezing temperatures and moisture. The Pacific Ocean and the Puget Sound give us cold winter air moving south from the British Columbia interior can push us below freezing. But combining both ingredients at the same time is more difficult. One basic scenario develops when an area of low pressure moves over the water just long enough to pick up moisture, but if it stays there too long, the mild ocean water will warm the air and then we see rain instead of snow. Because of this warming effect of the water in marginal situations, you're most likely to find snow inland away from the sound. Another way we can see snow is when it comes from the north as an Arctic front. The front lifts the moist ocean air over the Puget Sound region. And we end up with a major snow and ice event like we saw in November of 2006, when Quest Field looks more like the frozen tundra the Green Bay Packers are used to. We also have a few wild cards, what may be surprise snow for some, and elevation plays a big role.
Here on Cougar Mountain, the elevation is about 1,500 feet. If the freezing level was also at 1,500 feet, if it was 32 degrees right here, it would make sense that we would see snow. Meanwhile, when you drive down about halfway, temperatures will be a little bit warmer than freezing, and we can still see snow. The reason, it takes a while for snow to melt once it enters that warmer air, so we can see snow falling or even sticking about 1,000 feet below what we call the freezing level.
In heavier showers, you may find snow as much as 2,000 feet below the freezing level. At times, the snow may drag cold air to the surface, lowering the freezing level. If the snow falls long enough, we can see some temporary and spotty accumulations. We also have our version of lake effect snow, famous in the when very cold air moves across the eastern strait, it gains moisture, And when it's forced up the side of the Olympics, we can see snow around Port Angeles while everyone else is dry. Whether the snow is hit and miss or a widespread hit, snow in western Washington deserves the attention it gets.
On the positive side, these huge snowpacks provide us with water and electricity during the dry summer months. And it gives us lots of fun things to do during the winter. But too much snow can give us headaches, especially for travelers through the Cascade Passes. In 2005 and 6, Washington DOT plowed off enough snow to fill Quest Field more than 7 times. And when it falls in certain patterns, it can become a powerful and dangerous force, an avalanche bearing everything in its path. Last winter, Snoqualmie Pass was closed by snowfall and avalanches for over 175 hours, costing Washington's economy almost $50 million. And there is a human toll. A record 9 people died in backcountry avalanches in our state last winter. Avalanches aren't just caused by a lot of snow, but by the way it falls. Variations in the temperature, the winds, even the humidity produce layers in the snow.
So this is our top crust right here.
Most layers stick together and just pile up, but sometimes a weak layer can show up where the snow above isn't well attached to the underlying layer. Like a melting slice of ice cream, a slab avalanche can easily slide off an underlying, a slippery layer in between. The mechanism for an avalanche weak layer is different, but it's the same idea. One layer of snow sliding off another. As the snow continues to build up above a weak layer, it finally puts too much weight on it, and the snow slides off as a dangerous slab avalanche. This can send tons of snow plummeting down a mountain slope, sometimes at speeds greater than 100 miles per hour, with enough force to crush cars, buildings, and people. As a preemptive strike against avalanche danger, Washington DOT does avalanche control on the highways. The concept is simple. Bring the avalanches down when no one's in the way. When forecasters decide that avalanches are almost ready to come down, they close the highway. Then they set off explosives to shake the slope and bring down the avalanches. Blasting works most of the time, except when the snow falls too fast for control crews to blow it down, like last winter, and that's when we can see long highway closures.
The Olympics pull a tremendous amount of water out of the sky. Some parts of the range receive over 200 inches of rain a year. Studies of precipitation in the Alps have revealed how ridges, sharp changes in elevation, drastically affect the amount of rain.
The main Cascade Passes get between 350 and 450 inches of snowfall a year. Stevens and Snoqualmie Passes get a snow boost thanks to the Puget Sound Convergence Zone. And cold air from eastern Washington helps refrigerate the low Cascade Passes, often keeping the snow from changing to rain. However, both Mount Baker and Mount Rainier get over 600 inches of snow every year. Why? Mount Rainier catches the prevailing southwesterly storm winds. These bring moisture directly in from the Pacific without losing any to the Olympics. In addition, the measuring station at Paradise is over a mile high, which means more precipitation falls as snow rather than rain. Mount Baker's huge snowfalls are generated in a different way. Winds from the Strait of Juan de Fuca and the Strait of Georgia form yet another convergence zone that funnels moisture directly at Mount Baker. And it's the westmost of the North Cascades, so it's the first peak in line to soak up the snowfall. In sharp contrast, Mission Ridge has a climate more typical of the Rockies, drier and sunnier. It only receives about 200 inches of snowfall a year, but the snow tends to be much lighter and drier, and its colder climate allows for more extensive snowmaking to cover the slopes. Crystal Mountain is kind of a hybrid. It averages about 350 inches of snow per year, even though Mount Rainier blocks some of the snow headed for it. But the volcano also seems to act as a filter, taking out much of the wettest snow coming in from the Pacific and giving Crystal drier snow and more sunshine between storms. And throughout the winter, we keep you updated on the exact conditions at the ski areas with our ski report each day on King 5 Morning News and King 5 News at 5.
The southwest region of North America already is one of those parts of the world that seems to be becoming drier, more arid. This is part of a more general phenomenon whereby what we think of as the subtropical dry zones are spreading away from the equator towards the poles. We see both in observations and in future climate projections that southwest North America especially gets markedly drier, experiences repeated drought-like conditions. This would clearly be problematic for the people living there, including food production in California. At the same time, you have factors like the warming of the region is leading to melt of the snowpack in the Sierra Nevada mountains in California, and when that snowpack goes, that radically changes the supplies of fresh water for irrigation, agriculture, and for the people living in that densely populated region. Also, a more dry climate would be associated with probably more frequent forest fires and threats from that. So we could be looking at one region of the world which is incredibly developed and people are incredibly well off, but actually might be vulnerable to quite a striking qualitative change in the nature of the climate, which will require considerable adaptation.
Starting out with some heavy lake effect snow across the Great Lakes, as much as 20 inches lee of the Great Lakes, and a big burst of cold air. Sub-zero temperatures 15 to 20 below zero in spots, but a big warm-up coming up January 4th through the 6th across the central part of the country. Places getting 20 degrees above normal and even warmer than that. And then around the 8th and 9th, a big snowstorm shaping up for the upper Midwest, northern plain states. Could be some blizzard-type conditions, also heavy snows and heavy rains over the Pacific Northwest.